Hey folks, I'm Mr. Hartzler, and I want to talk to you about solving multi-step equations. And we need to do that by really just starting off with some examples here. I have 3x plus 5 equals 20. I need to subtract my 5 over. I need to isolate my term with x's in it. So now I have 3x equals 15. Now to get x truly by itself, I have to divide by 3 or multiply by 1/3, right? Same thing. We learned about that back in the multiplicative inverse video. So x equals 5 now. Nice. We go off to the right though, there's more things happening. I have x's on both sides and I have constants on both sides. I need to get all of my x's over to wherever most of my x's already are. So that's over on the left. So I'm going to subtract 5 x's over. That gives me 5 x's over there, and then everything else is just going to come straight down. That plus 7, that minus 14, all that's just coming down. Now I have to get this 5x by itself, so I'm going to subtract 7. And now 5x equals a negative 21. And that's a bummer because this is not going to break up evenly. But I need to divide by this 5 here so that I can get x truly by itself. So x equals negative 21 fifths. This is an improper fraction, which is fine a lot of the time. But there are times where we ask you to put this in a mixed fraction. A mixed fraction has, normal number and then a fraction off to the side. So how many times does 5 go into negative 21 perfectly? Well, it is at negative 21, so it's going to be a negative number. And 5 goes into 20 4 times evenly, right? That will get you all the way up to the 20. But then I still have 1/5 left over. So I have a 1/5 next to that. So again, either of those is fine unless they ask for one of them specifically. Let's go on to our next ones. I need to get this 6x by itself, so I'm going to add 8. So 6x equals 24. Then I need to get x by itself, so I have to divide by the 6. So x equals 4. Off to the right, not too bad, right? I just have to subtract my 1 first, and that's to isolate my x term. So now I have 12x's equals 24. How do I get x by itself? Well, I need to get rid of that 12, so I can divide by 12 or multiply by a 12th. Either one will get the job done. On the left, that all cancels, and then I have x equals 24 times 1/12, or 24 divided by 12, however you like to think about it. That just gets me a 2. Now we've got some that look a little more challenging, right? I need to still get the stuff with x in it all by itself. So I'm going to add this 4 over. Adding that 4. So I have x over 3 equals 14. Now how do I get the x by itself from here? Well, we've done one similar to this now, right? This looks a lot like one of our previous lessons. So I actually just need to multiply by 3. It'll cancel on this side, but I have to do that same thing to the other side. I can't just pick and choose what I'm doing here. So x equals, and 14 times 3 is 42. Off to the right, same thing. Isolate the stuff with x's in it. So I need to subtract 7. So x over 6 equals 13. Now I need to get rid of that 6 because I want x by itself. So I need to multiply by 6 on both sides. That gets me x equals, and this is 13 times 6. I like to do it like this. 13 times 6 is the same as 10 plus 3 times 6, which is, if I distribute that 6 in, is 60 plus 18. Adding those two up, and I get 78. Alrighty, let's move on to our next one. And they stay kind of challenging. So I'm going to subtract 10 because I need to isolate the stuff with x's in it. All right, isolate that whole term with x's. Then I'll try and get just the x by itself. So I subtracted the 10 and I get a negative 8. I'm going to do this in each piece here. So I'm going to multiply by my 8 first. And now I have 5x equals a negative. 8 times 8 is 64. Now I have to divide by 5. So x equals a negative 64 over 5. Okay, let's put that in a mixed fraction, as we've been doing that a lot lately. So 60 definitely goes in, or has 5 definitely goes into 60. and that's going to be 12 times. And it is a negative out in front, so it's going to be a negative 12, and then there was 4/5 left over. But again, either of those is fine unless they ask specifically for a mixed fraction. Off to the right, same setup. Isolate the thing with x's in it. So I'm going to add 1. 7x over 15 equals 23. This one is going to be a little bit messy, right? Multiply by 15, multiply by 15. Cancels on the left. That takes a little bit of math though, right? So I'm going to do this like 20 plus 3 times 15. 15 times 20 gets me 30 with an extra 0 on the end, right? Because 15 times 2 is 30, but there's an extra 0. 15 times 3 gets me 45, so that's 345. 345. And that 7x is still there. I have to divide by 7 now. Oof. And that is likely to not be pretty. I'm going to cheat here and pull out the old calculator. 345 divided by 7 gets me a 49. So I could either leave it as 345 over 7, or to put that in a mixed number. Since it's a 49 on there, right? I see a 49. So it's definitely going to be 49 perfect times, but then there's some decimal. So what is 49 times 7? 343. So that means there's 2 7s left over, because it was 343, and that's too short of 345. That part I know is a perfect 49, and that part is then still over the 7. But you can make a calculator do a lot of that work for you, and it's really not too bad. Oh, that's it. Hopefully this was helpful for you, and I hope all of you have a great rest of your day, and hopefully you learned something here. Keep doing math carefully and with enthusiasm, folks.